Now, nowhere are you going to find this in a textbook or anywhere. This is like me trying to verbalize your thinking for when you are given, let's say, 3 different graphs that have all been graphed on the same coordinate plane, and they ask you to identify which one is the original function, which one's the first derivative, which one's the second derivative. Okay, so literally, I just made this up, and it was me trying to verbalize thinking. All right, so we're going to read them. We're going to go through it. Then we're going to attempt to apply them. Okay. All right, so when trying to identify graphs of f, f prime, f double prime, I could even go up to f triple prime. All right, you want to check 2 main things. All right, first, you're going to look at your max and min points. Okay, so you're going to pick one of the graphs, find the max and min points. The derivative at these points will be 0, right? Because, let me move this. If I have a function like this, my derivative is the slope of the secant line, right? So at a max, my tangent line, the slope of the tangent line is the derivative. So that's 0, right? So if I had another graph, then this, at this point, coming down here, this would have to be the original function. This would have to be the derivative, because the derivative would have to be at 0. Okay, because it's a horizontal tangent line. Okay. Now, it says the derivative of these points will be 0. Follow the max min point down to the x-axis and see if one of the other graph crosses the x-axis at that location. If it does, follow that graph until you get to another max min point. Repeat the process by following the max min points down to the x-axis and see if the last graph crosses the x-axis at that location. So by doing that repeatedly over and over and over, you're going to be able to conclude which one has to be the original function, first derivative, second derivative. Okay. And this is going to be a lot of trial and error as you're doing this. All right. Now, so that one I use first and the most. All right. Now, the second thing you can do is you should also consider that when you are checking the derivative of a function and it is negative, then the graph of the derivative is below the x-axis. Say that again. You should also consider that when you are checking the derivative of a function and it is negative. So picture those secant lines. When the slopes of those secant lines are negative, the graph of the derivative should be below the x-axis. And when you are checking the derivative of a function and it's positive, so those secant lines are positive, have positive slopes, the graph of the derivative would be above the x-axis. Okay, now all that is just me trying to verbalize what the heck we're going to do. Okay, all right, so let's get some more graphs out of here. Let's get rid of that piece of paper in case that shows through. Okay, I color coded these because they were dotted and hashed and all that other kind of stuff, but made it very difficult. Okay, so I don't care. Pick a color, pick a graph you want to start with. You can pick the blue one, you can pick the green one, you can pick the pink one. Doesn't make any difference. All right, let's say I'm going to pick the green one because you're just going to randomly start somewhere. And I'm going to start with my max min points. All right, so if this is my original function, then one of the other graphs should cross the x-axis, right? Because the derivative of this would be 0. So I'm going to go to the x-axis. All right, yay, it worked, right? Now I'm going to choose to continue, all right, along the blue line to another max or min point. Okay, so let's just go this way. I come here. Now, the derivative of this means that the pink line should cross right here. But did it? No, it went in a circle, didn't it? All right, so that's not going to help us. We don't want to start there. Okay, so let's start with the blue one. All right, here's the max min point. Let's go down to the x-axis. Yep, so we're good there. Blue could be original. Green could be first derivative. Now follow this along to the next one. went back in another circle, didn't I? Okay, so let's start with the pink one. Here's the max min point. Its derivative would cross the x-axis. All right, are we good? Yep. Now follow the blue line along till another max. Here's another max or min. And then its derivative would be at the x-axis. So did that work? So then that means the pink one is F. F prime. Green one is F double prime. And I didn't even have to use the second rule. You got to be thinking and paying attention and watching, or you're not going to get this. Okay? And especially if we don't revisit this again for 2 weeks. Okay. All right, so there's that one. Let's try another one. Ooh, I've got like 1,000,000 copies of the same graph. I don't need 1,000,000 copies of the same graph. All right. Okay, let's look at these. All right, you almost can't tell the difference between the blue and the pink, I think, or the blue and the purple. All right, now, on this one, okay, let's go back to this one for a minute. Let's talk about this. Okay, so when I first glance at this, does this look like any of the functions that we've memorized? No. It's not an x squared. There's not an x to the third. There's not a square root function in there. There's no rational ones in there. So you clearly have to use either the first rule or the second rule. Okay, now on this one, though, on the other hand, if I glance at those, if I just glance at them, do some of them look familiar? Like graphs that we've already memorized? Okay, doesn't the blue one, what's the blue one? The blue one is x to the third with a negative coefficient. All right, do we recognize the green one? X to the fourth with a negative leading coefficient. So if I already know that this one is an x to the fourth and I already know this one is an x to the third, which means the blue one has to be the derivative of the green one. Ooh, say that again.
And since the zeros on the green one line up with the zeros on the pink one, it means that the pink one is the original function.
Yeah. So what he did was he went along this pink one. All right, let's use my first rule. Okay, so pink come down to a max. All right, and then its derivative should be at the x-axis. And we already knew this one has got to be, this one's got to be the derivative of that one. So that means the pink one then has to be my original function. The green one then would have to be the first derivative. And the blue one then would have to be the second derivative. And this one started with the fact that, oh, hey, some of those on there I recognize. Because some of them you're going to recognize because we've memorized a bunch of them. Others of them you will not memorize, have any of them memorized. Okay. Let's see if I can do another one that would be a relatively easy one that you should be able to get on your own. Okay, so let's do this one. I'm not going to talk you through this one. I want you to do this. Label them. Obviously, we're going to have an original function, a first derivative, a second derivative, and a third derivative on this. All right, so on your paper, sketch it. You know, I don't know, sketch it, write it down, come up with which one is which. Okay, anybody want to go? Josiah doesn't get to go. Anybody else want to go? Dane, what are you thinking? Say what? You're still working through it. Quentin, you got it yet? Ooh, D, C, B, A. Oh, very good. And he said that in a very good order. It's D, C, B, A. All right, so F, F prime, F double prime, F triple prime. All right, now keeping in mind clearly this one has to be x squared, right? Because that's just a basic parabola. All right, then this one is your basic cubic. All right, so that makes sense so far. Now, this one, x squared, but it could also be an x to the 4th, and the same thing for this. There you go. That's it. All right, that's because remember, hills and valleys, vary as the exponents go up. All right, but do the test. Come down here to the first maximum point. Okay, its derivative would be here. Follow the pink line, round to its next max. Its derivative would be here. Now you would either have to choose the blue line or the green line. If I do the blue line, there is no more. If I do the green line, so that's going to help me at least get the order for this, and then down to those two, and then those two should have been independent. Okay. All right, so that one would have been, for me, that one would have been a relatively easy one because they are ones that we pretty well already know. Okay. All right, now let's go with one that we don't know as well. All right, so looking at these, we don't really know, right? Because we don't recognize them as being x squareds, x to the thirds, they're like just random things. Okay, so let's start in. All right, which color do you want to start with? I want to start with green. Okay, so if I start with green, I'm going to come along to the green till I find a maximum endpoint right in here. And it varies, but if it's in here somewhere, then I can say, yeah, the derivative is there. Follow the blue line along to its max point, and then come down. Now, when I come down to here, since I don't want to, I started with the green, I don't want to go back to the green. Did it hit on the pink? Mm-hmm. Did we get lucky right off the bat? Yeah, we did get lucky right off the bat, didn't we? We did. Wow. Okay, we did. So why did you start with the green? Did you just randomly pick green, or were you thinking ahead?
I picked green randomly at first, but I had already figured it out by the time you asked to start.
Because I did a lot of talking in between there. Right. Okay, so there's the original blue line is that. Pink line is double prime. All right, now this was not very interactive from your part because you actually had to be focusing and listening to me verbally. And did I use rule number 2 at all? I did not. Now, could we apply rule number 2 on here and just see if it works?
Yeah.
We could, right? Okay, so let's do that on this one. Let's see how it works. All right, so let's take a look at the green line because we know that's my original function. Okay, so if I go from here to here, I'm marking this up really bad here. All right, so all of these secant lines, or tangent lines, all of these tangent lines are going to have what kind of slope? Positive slopes, right? No matter how I draw the tangent line. Okay, if these are just in between here, every tangent line I draw is going to have a positive slope, which means then its derivative would have to be above the x-axis. Well, we said that the green line's derivative was the blue line. So from here to here, is the blue line all above the x-axis? It is. So that's the second rule. You pick a section that you want to look at where the slope is the same. Okay, I ought to be able to do that on the blue to the pink line. Okay, so a good part, let's see. If I'm looking at the blue, if I go in between here and here, the reason I chose this section on the blue line is because what? Every slopes are negative. Every tangent line, I keep calling them secant lines, every tangent line here is going to be negative. All right, we said that the blue line's derivative is the pink line. Okay, so in between these two lines, the pink line should be completely below the x-axis, and it is. So a lot of the times I use the first rule to determine it, and then I back it up or justify my answer with the second rule, because then I can go through, and once I decided which one is which, then I can go back and I can look at those slopes of those tangent lines. All right, now normally under normal circumstances, we would then, I I would put you in pairs and you would work on some really hard ones of these. All right, but I'm going to do it a little bit different this year. I mean, we're with our hybrid learning at the beginning and our e-learning days on Wednesday, I'm adjusting and we're doing things a lot differently than I have in the past. So we're just going to let you marinate with this. I'm pretty sure there's at least 2 of these questions on tonight's homework. You think about it, practice them gradually, and then in about a week and a half, we're going to do that group activity where you will get together in groups, you'll have some graphs, and then you'll have to use the 2 rules. Okay. All right. So that being said, I think I'm all done for today.